You are tuned to Iri-e-learning and I am your host, Teacher. In this mole concept lesson, we will examine mole calculations using proportionality statements. Check the description box for the link to the playlist with all the lessons related to this unit. By the end of this lesson, we should be able to use proportionality statements to calculate moles, mass, and molar mass of elements or compounds. So what are proportionality statements? Well, proportionality statements simply indicate that two ratios are equal. So we are going to go straight into an example. Example 1. How many moles are in 26.5 grams of sodium carbonate, Na2CO3? So first step, find the molar mass of sodium carbonate. If you have not yet done so, please review the video in which we looked at calculating molar mass and relative masses. When we are calculating the molar mass, the first thing we need to do is to record the quantity of each element in the compound, after which we're going to multiply the quantity by its molar mass. So the molar mass of sodium is 23 grams per mole multiplied by 2. That gives 46 grams per mole. The molar mass of carbon is 12 grams per mole multiplied by 1 carbon, giving 12 grams per mole. Then for oxygen, the molar mass of 16 grams per mole is multiplied by the 3 oxygens, and that gives 48 grams per mole. Then we add all the molar masses of the elements within sodium carbonate, and we obtain 106 grams per mole. Therefore, for step 2, we're going to write the molar mass as a statement. We just calculated that the molar mass of sodium carbonate is 100 grams per mole. Therefore, as a statement, we say that 1 mole of sodium carbonate has a mass of 106 grams. So how do we use our proportion statements? Well, step 3, we need to record the second statement based on the question asked. The question asked, how many moles are in 26.5 grams of sodium carbonate? So we need to write that as a statement. Now, we don't know how many moles. We need to find the number of moles. So we're going to give it an unknown, and we're going to call it P. So P moles of sodium carbonate has a mass of 26.5 grams. Then finally, we're going to link the two statements together. And so we know that 1 mole of sodium carbonate has a mass of 106 grams. And that's the molar mass statement. Then from the question, we need to know how many moles of sodium carbonate is present in a mass of 26.5 grams. So the statements must be written in the same fashion. If for the first statement we begin with moles and end with mass in grams, we must write the second statement in the same fashion, beginning with mole and ending with mass in grams. Now we're going to shorten our proportion statements and create what we call ratios. So we now have 1 mole divided by P mole would be equal to 106 grams divided by 26.5 grams. Now that we have equated the two ratios, the next step is to cross-multiply or find the cross products. First, we identify the position of the unknown and begin with the unknown for the first cross product. In this way, we will have the unknown on the left side of the equation, which makes it simple for calculations. So, P multiplied by 106, and that gives us P times 106. And that would be equal to the next cross product, which would be 1 times 26.5. Then we solve for P. In solving for P, we divide both sides by 106. And on the left side, we see that the 106 cancel each other, which leaves P by itself on the left side of our equation. So as a result, P is equal to 1 times 26.5 divided by 106. And the answer works out to be 0.25 mole. Therefore, 0.25 mole of sodium carbonate has a mass of 26.5 grams. Example 2. How many moles are in 0.05 grams of ammonium sulfate? Chemical formula, open brackets, NH4, close brackets, 2SO4. In this question, we need to find the number of moles. The mass is given 0.05 grams, and we can find the molar mass of the ammonium sulfate. To find the molar mass, we note the quantity of each element within the compound. There are 2 nitrogens, 8 hydrogens, 1 sulfur, and 4 oxygen atoms. Then the quantity of each element is multiplied by the mass of 1 mole, which is equated to the mass number on the periodic table. When we work it out, we get 132 grams per mole for the molar mass of ammonium sulfate. If you're unsure how to do the calculation, review the video on calculating molar mass and relative masses. Now we're going to create our proportion statements. So for step 2, we are going to start by recording the molar mass as a statement. Now we just did the calculation and we saw that the molar mass for the ammonium sulfate is 132 grams in 1 mole or per mole. Therefore, we write that statement which says 1 mole of ammonium sulfate has a mass of 132 grams. The second proportion statement, we are going to use the information given in the question. Now, we don't know the number of moles. It is unknown, so we are going to use a letter in the alphabet to denote the unknown number of moles. And that unknown number of moles is found in the 0.05 grams of ammonium sulfate. Therefore, we can write the statement that says Y moles, and you can use any letter of the alphabet. I'm choosing Y. Y moles of ammonium sulfate has a mass of 0.05 grams. Now we get to step 4, where we have put our proportion statements together. 1 mole of ammonium sulfate has a mass of 132 grams, and Y mole of ammonium sulfate has a mass of 0.05 grams. Now, it's very important to note that when you are writing your proportion statements, both statements must be written in the same fashion. So if you start with moles and end with grams for the first statement, then the second statement likewise must start with moles and end with grams.
Next, we generate
and equate the 2 ratios. Therefore, we have 1 mole divided by Y moles is equal to 132 grams divided by 0.05 grams. For step 5, we're going to multiply to find the cross products. And we always start with the unknown because we want the unknown to be on the left side of the equation. It makes it simple. So we find our unknown in the ratio and we start with that cross product first. So what we have is Y multiplied by 132 is now equal to 1 times 0.05. Then we're going to make Y the subject of the formula. And in order to do that, we need to get rid of the 132 from the left side of the equation. Since we're multiplying by 132, we do the opposite operation of multiply, which is divide by 132 in order to cancel 132. And remember, whatever we do on one side of the equation must also be done on the other side of the equation. So as we can see, 132 in the numerator will cancel 132 in the denominator. As a result, we're left with Y is equal to 1 times 0.05 divided by 132. This results in a lengthy decimal number. And if you note, there are 3 trailing zeros behind the decimal point. So it's best to express this number in standard form or scientific notation. That is the format A times 10 to the power of n. So we first step to express in standard form, we need to move the decimal point in the direction in which it will then get behind the first significant number or the first significant digit in this number. And the first significant number is actually 3, so we need to move the decimal point from this location to behind the 3. And it's important to count how many times we have moved it because it will give us the value of n. And also note, because we are moving the decimal point to the right of the number, n will be a negative value. So let's go 1, 2, 3, 4. So we have moved the decimal point 4 times to the right, so n is equal to negative 4. Now we can get rid of all the zeros in front of the first significant figure because they are of no value. And what we are left with is the value of A. And we will round the value of A to 2 decimal places or 2 places of decimal, which means we want to have 2 numbers behind the decimal point. So we have 1, 2. We draw our imaginary line. Then we look to see what is a number occurring behind the imaginary line. If that number is greater than 4, we add 1 to the number in front. And so what we're now left with is 3.79 because 8 plus 1 gives 9 and we get rid of anything occurring behind the imaginary line. So A is now 3.79. So consequently, our answer, the Y, would be equal to 3.79 times 10 to the negative 4 mole. Therefore, 3.79 times 10 to the negative 4 mole of ammonium sulfate has a mass of 0.05 grams. Example 3. 9.125 grams of compound X contains 0.25 mole. What is the mass of 1 mole of compound X? In this question, we have no known compound. We have an unknown compound, compound X. Therefore, step 1 would involve writing the proportion statements given in the question. So let's see what proportion statements are given. The first one is that 9.25 grams of compound X contains 0.25 mole. And then the second one is that we need to find the mass of compound X in 1 mole. Therefore, our two proportion statements would be 9.125 grams of compound X contains 0.25 moles and Y grams of compound X contains 1 mole. We use Y because the mass of 1 mole of compound X is unknown. So now we create our ratios where we have 9.125 grams divided by Y grams is now equal to 0.25 mole divided by 1 mole. And from this point, we're then going to multiply to find the cross products. And as we mentioned before, we start with the unknown. So here we have Y times 0.25 is equal to 1 times 9.125. Now we have to make Y the subject of the formula. On the left-hand side of the equation, we multiply Y by 0.25, seeing that we're multiplying. In order to cancel that value, we want to get rid of the 0.25 from the left side of the equation. We do the opposite operation to multiply, which is divide. And so we divide both sides of the equation by 0.25. And of course, the 0.25 will cancel on the left side of the equation. And that leaves us with Y is equal to 1 times 9.125 divided by 0.25. Consequently, our answer becomes 36.5 grams. Therefore, it means that 36.5 grams contains 1 mole of compound X. In other words, compound X has a molar mass of 36.5 grams per mole. Example 4. The molar mass of copper oxide, CuO, is 79.5 grams per mole. What mass of copper oxide contains 0.015 mole? Starting with step 1, we're going to write the proportion statements given in the question and to identify what is to be found. So our first statement is actually the molar mass of copper oxide because it's telling us that 1 mole of copper oxide has a mass of 79.5 grams. The second statement involves the unknown mass of copper oxide that contains 0.015 mole. Therefore, our proportion statements would be 1 mole of copper oxide has a mass of 79.5 grams. And again, if we start with mole for the second statement, we should also begin with moles. So we have 0.015 mole of copper oxide has a mass of P grams. And P here is the unknown because we don't know that mass. That is what we want to find out. So we're going to create our proportion statements. So we have 1 mole divided by 0.015 mole as our first ratio. And we're going to equate it to the mass ratio, which is 79.5 grams divided by P grams. For step 2, we will multiply to find the cross products. So identify the location of your unknown and we will start there. So we have P times 1 is equal to 0.015 times 79.5. Therefore, P times 1 is P, and the answer works out to be 1.19 grams. Therefore, we know that 0.015 mole of copper oxide has a mass of 1.19 grams. The lesson summary point is proportion statements can be used for calculating moles mass or molar mass. It's quiz time. You have 5 seconds to answer each question after it is read aloud. If you need more time to complete the calculations for each question, pause at the start of the music. When you're through, then you can continue playing the video. Question 1. How many moles are there in 51.75 grams of sodium? A. 0.4444 mole. B. 4.70 mole. C. 0.2126 mole. D. 2.25 moles. The answer is D, 2.25 moles. How did we arrive at the answer? Using the proportion statements, we know that 1 mole of sodium has a mass of 23 grams using the information from the periodic table, and Y moles of sodium would have a mass of 51.75 grams. We create our ratios, moles over moles and grams over grams. Then we cross multiply starting with the unknown. So Y times 23 is equal to 1 times 51.75 grams. We rearrange to find Y as the subject of the formula. So we divided both sides by 23. 23 cancelled on the left. And so we are left with Y is equal to 51.75 divided by 23, which works out to be 2.25 moles. Question 2. 1 mole of compound P has a mass of 132 grams. How many moles are there in 3.64 grams of compound P? A. 0 moles. B. 0.0276 mole. C. 2.76 times 10 to the second moles. D. 0.02 mole. The answer is B, 0.0276 mole. So let's look at our proportion statements. We know that 1 mole of the compound P has a mass of 132 grams. That was given to us in the question. And we want to find how many moles of compound P has a mass of 3.64 grams. So we set up our ratios, mole over mole, grams over grams. Starting with our unknown, we find our cross product. So Y times 132 is equal to 1 times 3.64. We rearrange our equation to make Y the subject of the formula. We end up with Y is equal to 3.64 divided by 132, which works out to be 0.0276 mole. Question 3. The molar mass of potassium oxide, K2O, is 94 grams per mole. How many moles are present in 0.005 grams of potassium oxide? A. 5.32 times 10 to the 5 moles. B. 5.32 times 10 to the negative 5 mole. C. 0.47 mole. D. 1.88 times 10 to the negative 4 mole. The answer is B, 5.32 times 10 to the negative 5 mole. Let's look at our proportion statements. We know using the molar mass given for potassium oxide that 1 mole of potassium oxide has a mass of 94 grams. And we want to find out how many moles of potassium oxide has the mass of 0.005 grams. Next, we set up our ratios. The mole over mole is equal to grams over grams. And we start with our unknown and cross multiply. So we have Y times 94 is equal to 1 times 0.005. We rearrange to make Y the subject of the formula, and we obtain 0.005 divided by 94, which works out to be 5.32 times 10 to the negative 5 mole. Question 4. A student needs 0.0125 mole of compound X for a reaction. If compound X has a molar mass of 60 grams per mole, what mass of compound X should the student use? A. 0.75 grams. B. 0.0002 grams. C. 4,800 grams. D. 7.5 grams. The answer is A, 0.75 grams. So let us look at our proportion statements. We have the molar mass of compound X to be 60 grams per mole. So 1 mole of compound X has a mass of 60 grams. For the second statement, we have the moles of compound X, which is 0.0125, and we need to find out the mass of compound X that contains that amount of moles. So we call the mass B grams because it is unknown. So we set up our ratios. We cross multiply on the diagonals. B times 1 would be B is equal to 60 times 0.0125. And that works out to be 0.75 grams. Question 5. There is 0.25 mole in 26.5 grams of substance P. What is the molar mass of substance P? A. 26.5 grams per mole. B. 424 grams per mole. C. 106 grams per mole. D. 100 grams per mole. The answer is C. 106 grams per mole. So let's see what the proportion statements would look like. We want to find what is the mass in 1 mole of substance P. Therefore, 1 mole of substance P would have an unknown amount in grams, and we call that unknown S in this instance. But we also know that 0.25 mole of substance P has a mass of 26.5 grams. So we set up our ratios, mole over mole, grams over grams. We find our unknown and we cross multiply products. So we have S times 0.25 is equal to 1 times 26.5. We rearrange to make S the subject of the formula, and we end up with 26.5 divided by 0.25, which gives 106 grams. Therefore, the mass of 1 mole of substance P is 106 grams, which we record as grams per mole for the unit.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.